here to sensors and let's just take a look. Coolant temp is 155. So we're technically still in warm-up enrichment. We actually go back here to flip into fuel tuning. We take a look here. We find that our coolant air fuel offset is zeroed out. Let's go back in here to learn tuning. Coolant enrichment. We see it's almost at 100%. 100% means we have no warm-up enrichment. So right now we've exited warm-up enrichment. We're at 100%. The engine is considered to be warmed up here around 160 coolant temperature, so we're probably about 160 if we flip back here to sensors. 163, so we're at 163 right now. So that looks okay. Looking at a couple key things here, now that we have our fuel kind of sorted out, we're not going to go after that anymore. Looking here, we have our TPS reading 0, that's good. Looking here that our map sensor is reading about 50, 60 kPa, that's okay. Oil pressure here is 65, 66 PSI. Flex fuel is still registering 13%. Battery voltage here is 14.1 volts. The alternator is charging, so that all looks good. Just kind of doing a quick glance here at all of our really important sensor data. Now what I'm going to do is take a look at the idle control. Let's see what it's registering now on a relatively warm idle, and then we can start to take a look at some of our startings, making sure the car cranks up and it fires properly. Also making sure that if we rev it and come back into idle, that everything's sorted out there so that it holds a stabilized idle. The goal with this video was to go through the basic sensor check, upload the base map from the last video, and then making sure that the engine holds its own idle and it starts, because we can't do anything beyond this point here. If the engine wants to stall all the time or doesn't want to hold its own idle very well, we can't start to drive the car. We need to get this worked out first. So this is always the next order of operations after you've created the base map and you got the engine fired up and running. Let's go in here and toggle right into idle tuning. And what we're paying attention to here is the IAC position. Right now it's reading approximately 15-16%. I'd like to see it about 10, maybe 15% on a warm idle. Now I did go in and I did adjust my set screw on the throttle body. I'm having more mechanical airflow contribution from my throttle plate because the set screw is open more rather than relying on the idle control position. So we should see this anywhere between 10 to 15, maybe 20% at the most. If it's going to be lower than that, if it's at 0, you may need to go in and turn your idle set screw down a little bit and let less airflow in so the idle control is essentially parking itself at 10-15%. If you're finding that it's much higher than this, let's say it's at 30, 40, 50, 60, 80%, that means you need more airflow contribution mechanically from your throttle plate and you need to adjust that set screw. So I've already done that. If you are adjusting the set screw, make sure you do go back in after you've made the adjustment, go in here to TPS auto set and do the minimum and maximum TPS recapture, because it will scale and move your throttle position because you're moving the position that shaft is open, so your new minimum throttle will be different and you need to compensate for that. So this looks like it actually worked out. I just took a guess, 2 extra turns from the throttle body as it shipped from the manufacturer, and that seems like it did the trick. So it's right where we want to be here for IAC position. A couple other things to take a look at here are spark timing feedback. We can see the base timing commanded in our spark timing table. We jump into spark timing. That's going to be commanded here at roughly 15 degrees. 15-20 degrees is pretty normal for idle spark timing on an LS engine with a reasonable size cam. So we see that's going to be where the base timing's at. If we take a look at the ignition timing, this is adding a little bit more timing in the spark timing offset feedback to be able to hold it to the desired idle speed. We've set the desired idle speed at 900. Probably would have set this on this size cam around 800 if the injectors weren't so big. I've increased the desired idle speed through the idle control to 900 to be able to increase the amount of airflow coming into the engine and therefore increase the injector pulse width so the injectors run a little bit more linear in their operation, which seems to be working pretty well because the engine's idling relatively smooth at 14-to-1 air fuel. But what we're finding here is that we don't want to see this spark timing here adding, and if the base is 15, we don't want to see this being at something like 30 degrees of timing. That could mean that we need more idle airflow, and that could mean that we need to adjust the screw a bit more, also keeping in mind that our IAC position has to be factored in as well. So if you do see that your spark timing here, your actual ignition timing, the base timing is what's commanded from the table, the actual ignition timing is what it's correcting. If we see this correcting 30 degrees. Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.